I'm going to go through the setup of problem number 3 right now. Once again, if you did not do so already, try to set up problem number 3. I highly encourage you to do this. I cannot stress that enough. The only way that you'll get better at this is by doing it yourself. Alright, so without further ado, let's go through problem number 3. It says Mr. Ames is dragging a box full of books from his office to his car. The box and his books together have a combined weight of 134 newtons. If the coefficient of static friction between the pavement and the box is 0.55, how hard must Mr. Ames pull the box in order to start it moving? Okay, so it looks like that we're trying to actually pull it to get it to start to move. All right, so let's do our free body diagram right now. We have our box. Our normal force and our gravitational force acting on the box. And now we're pulling on the box, right? Does it say to the left or to the right? I don't think it gives any sort of direction in here. I'm scanning this right now. It doesn't really give any sort of direction. Let's just say that we're pulling it to the right. And what's this force right here? Well, this is our applied force. And is there any sort of force in this direction? Well, yeah, there's the frictional force. And now, is this a kinetic friction or static friction? Well, we're trying to find out how hard you must pull the box in order to get it to start moving. So hopefully you already said to yourself that it's a static friction that we're dealing with. All right, and what's the given information that we have here? Pulling this out. 134 newtons. What is that? It looks like it's combined weight of the box and the books. So this is our Fg. And what else do we have? It looks like that we have a coefficient of static friction of 0.55. How hard must Mr. Ames pull the box in order to get it to start moving? Okay, so what is the thing that we're trying to find here? All right. So, being that we have the weight of the box, we could figure out what the mass is of the box using that formula. Simply dividing 9.8 on both sides of the equation, we'll get our mass. Okay, and let's set up our two force equations. First of all, which direction is going to be our positive force, up or down? And which direction is going to represent positive for the forces along the x-axis, left or right? Hopefully you're saying to the right, and the reason behind that is because I know that the object's not moving to the right just yet, but that's the direction that we're intending the object to be moving when we're pulling on it. So therefore, let's say that the positive direction is going to be acting to the right. Now let's set up our two force equations. Sum of the forces. Okay, so we have the sum of the forces in the y direction. What are the forces going upwards? Hopefully you're saying to yourself the normal force. And then what are the forces going downwards? Hopefully you're saying to yourself the gravitational force. Is this object moving up or down at all? No, so therefore the acceleration in the y direction is equal to 0. 0 times any number is going to equal 0. Okay, and the forces in the x direction. Well, what are the forces moving to the right? Hopefully you're saying to yourself the applied force. Minus all the forces moving to the left. And is this object accelerating in the x direction, left or right at all? No, it's actually not even moving just yet. So if it's not moving, what is acceleration? Okay, and the setup for this problem is done.